Exercise 3.6, question number 2, third part. Third part. Ruhi travels 300 km to her home, partially by train and partially by bus. She takes 4 hours if she travels 60 kilometers by train and remaining by bus. So here total distance is 300 kilometers. Some part of it is covered by she takes 4 hours if she travels by 60 kilometers by train. So some of it is covered by train and remaining part, that is 60 kilometers, is covered by train. Remaining part means 240 kilometers is covered by bus. Now this is case 1. If she travels 100 kilometers by train and remaining by bus, she takes 10 minutes longer. In case 2, distance is same only, 300 kilometers. 100 kilometers are covered by train and remaining, that means 200 kilometers by bus. Okay. So find the speed of train and bus separately. Let speed of train equals to x and speed of bus equals to y kilometers per hour. We know formula speed equals to distance upon time, or time equals to distance upon speed. We know total time for traveling this 300 kilometers, that is 4 hours. So time taken by train plus time taken by bus is 4 hours according to first case. Time taken by train will be distance traveled by train upon speed of train, that is 60, and speed of train is x. Time taken by bus is distance traveled by bus upon speed of bus, that is y, equals to 4. Let this be equation 1. In case 2, time taken by train plus time taken by bus equals to 10 minutes longer, means 4 hours plus 10 minutes. So if I write 10 minutes in hours, it will be 10 upon 60, that is equal to 1 by 6. So I'll write it 4 1 by 6. Time taken by train will be distance traveled by train upon speed of train. Distance in this case is 100 kilometers. Speed is x. Distance in other part is 200 kilometers. Speed is y. And this mixed fraction, if I'll convert to improper fraction, 6 4 are 24 plus 1, 25 upon 6. These are the two equations which we need to solve. I am rewriting these two equations on the next slide. 60 by x plus 240 by y equals to 4. 100 by x plus 20 by y, 200 by y equals to 25 upon 6. These two equations are not linear equations in two variables, but they can be reduced to linear equations. So let 1 upon x equals to p, 1 upon y equals to q. Now our equation becomes 60p plus 240q equals to 4 and 100p plus 200q equals to 25 upon 6. We can further reduce these equations. So first equation, let us divide the first equation by 4, that it will be 15p plus 60q equals to 1. Let this be equation 3. For next equation, let us multiply by 6 by 25 on both sides. 6 by 25 we are multiplying on both sides. So if we'll multiply 6 by 25, this will be 24p and this will be 6 8s are 48q equals to 1. This is equation 4. We need to solve 3 and 4. Okay. I am doing by substitution method. So from equation 3, 60q equals to 1 minus 15p, or q equals to 1 minus 15p upon 60. Substituting this, that is equal to 24p plus 48 into 1 minus 15p upon 60 equals to 1. 12 fours are 12 fives are. Solving this further, that is 24p plus 4 into 1 minus 15p upon 5 equals to 1. So taking LCM or multiplying by 5 in entire equation, 5 into 24 will be 120p. 5 will cancel here, 5. So it is plus 4 minus 60p equals to 1. So 60p minus 1 60 60p. Here when we'll multiply by 5 in entire equation, this will also become 5. So 5 minus 4 equals to 1. P equals to 1 by 60. Substituting this P equals to 1 by 60 in equation 3, that is 15p plus 60q equals to 1, and P is 1 by 60. So 60q equals to 1 minus 1 by 4, that is equal to 3 by 4. Okay. Or q equals to 3 by 4, or q equals to 1 by 80. Okay. So now we got P equals to 1 by 60 and Q equals to 1 by 80. We have assumed P as 1 upon X and Q as 1 upon Y. So this is equal to 1 upon Y and this is equal to 1 upon X. Or I can write X equals to 60 kilometers per hour and Y equals to 80 kilometers per hour. Okay. So our assumption was that train's speed is X kilometers per hour. So this is the speed of train and this is the speed of bus. These are the answers.